day everyone. So this is Dr.VNSR Venkateswara Rao, working as Associate Professor from the Department of Chemistry in Institute of Aeronautical Engineering, Hyderabad, 543. So today I would like to give the topic on the one of the important polymers, nothing but most useful polymers, that is nothing but a polyvinyl chloride and Teflon. So polyvinyl chloride and Teflon. So first of all, before starting the topic, what are the contents involved in the today's topic. So first of all, for each and individual polymer, we see the preparation. After that, we see properties. Then explain the what are the applications or uses of the polymers. So first of all, basically we see the one of the important polymer, nothing but PVC. So PVC is nothing but the full form is nothing but a polyvinyl chloride. So polyvinyl chloride means we can understand what is the monomer vinyl chloride. So generally, what is the structure for polythene? That means what is the polythene monomer ethylene? Ethylene structure CH2 double bond CH2. So if you can replace the one hydrogen from this structure CH2 double bond CHCl. So that is nothing but a vinyl chloride. That means it is not a direct monomer of this polymer. So that's why it is need to prepare the first of all monomer. After that, it undergoes the additional polymerization to give a polymer like polyvinyl chloride. So that means we see the before starting the preparation of the PVC. First of all, we learn about the how to prepare the monomer of the PVC, nothing but vinyl chloride. After that, we see how to prepare the polyvinyl chloride. Okay, now all of you understand why you can learn about the monomer preparation in the case of the PVC. Okay. So first of all, the monomer used for the manufacturing of the PVC is nothing but a vinyl chloride. And already we see the structure of the vinyl chloride, that means the formula. So that means CH double bond CH Cl. So this is the structure for a vinyl chloride. Okay, so vinyl chloride is prepared by treating the acetylene with hydrochloric acid at 60 to 80 degrees centigrade and in the presence of a metal oxide as a catalyst. Metal oxide is a catalyst. I think all of you know what is the importance of the catalyst. So catalyst is a substance which can improve the rate of the reaction, and what is the condition? They cannot involve the product formation. So that is nothing but a catalyst. So first of all, catalyst is a substance which can improve the catalyst is a substance which can improve the rate of the reaction. So without involvement of the product formation. So what is the rate? Rate is nothing but a decreasing the concentration of the reactants with respect to time, or increasing the concentration of the products with respect to time. So that is nothing but a rate of the reaction. Such rate can be developed by the catalyst substance. And what is the condition? They cannot involve the product formation. So in this preparation of the PVC, we use metal oxides. Metal oxides means like transition metal oxide like cupric acid, ferric oxide, and another oxides like titanium oxide. All are these best examples for a metal oxides. So such type of the transition metal oxides will be applicable in the case of the preparation of a PVC. Okay, so from the writing you can understand by taking the examples of a acetylene. That means basically there are two types of the alkanes according to its nomenclature: alkane, and alkyne. That means acetylene. Acetylene means CnH2n minus 2. CnH2n minus 2. CnH2n minus 2. That means if n is equal to 2, acetylene means if n is equal to 2, what happens? C2 and H2 into 2, 4 minus 2, 2. That means it is the formula for acetylene. Then structure is nothing but a CH triple bond CH. CH triple bond CH. Because of the involvement of the triple bond, this is very highly stable. Well, compared to the single bond and a double bond, triple bonds compounds are more stable. So the best example for a triple bond compounds is nothing but a acetylene, CH triple bond CH, and it reacts with the strong acid, So what is the example of the strong acid in this reaction? Hydrochloric acid. So why you can choose the hydrochloric acid? Because of the volatile nature of the hydrochloric acid, and it reacts with the each other in the presence of a metal oxide as a catalyst in the presence of 60 to 80 degrees centigrade temperature. So in the presence of 60 to 80 degrees centigrade of the temperature to give a vinyl chloride, and it undergoes a additional polymerization. To give polyvinyl chloride. That means if it undergoes the n moles of the vinyl chloride, additional polymerization to give polyvinyl chloride. So this is the structure for polyvinyl chloride. Okay. Now all can understand the preparation of the polyvinyl chloride. So now let us discuss about what are the properties and uses of the polyvinyl chloride. So there are mainly two types of the PVC. One is rigid PVC. Rigid PVC is also called as unplasticized PVC. That means the plastic content will be very less in the case of the unplasticized PVC. That means they are generally having the hard and stiff nature. So that means it is chemically inert and a non-inflammable powder having high softening point of like 140 degree centigrade. So this is very high temperature for the softening of the polymer material. So that's why it is having the high strength and stiff material. That means this PVC is used for making safety helmets, refrigerator components, tires, cycle and motorcycle mudguards. So this is about the uses of the PVC. That means mainly the plasticized PVC and unplasticized PVC present in the types of PVC. So before starting the plasticized PVC, we discussed about the unplasticized PVC. So this unplasticized PVC is nothing but a chemically inert compound and non-inflammable, and the powder having a high melting point, that is nothing but a 148 degree centigrade. So this PVC is mainly applicable to making the safety helmets and refrigerator compounds. So these are very hard material and especially used for the making tires, cycle and motorcycle mudguards. They are also highly rigid substances. So after that unplasticized PVC, then we discuss about the plasticized PVC. So plasticized PVC means these are having the character nothing but plasticity. That means they can be molded into desired shape by applying temperature. So that is nothing but a plasticized PVC. That means it is produced by mixing plasticizers like disbutyl phthalate with PVC resin uniformly. So plasticizer PVC means this is nothing but the plasticity character. So that plasticity character is produced by mixing the plasticizers like disbutyl phthalate with PVC resin uniformly. That means it is mainly used for the making raincoats and table cloths. After that we see the handbags, curtains and electrical insulators, radio, TV components. So all type of the PVC shows for which wear. That means if the PVC, if the shoe is manufactured from the PVC, they can be used for the beach wear material. Okay, on the beside of the sea, especially we use the shoes like they are made with plasticized PVC because of the plasticity character. That means they can be molded by walking or running into desired shape to give the flexibility in the process, nothing but either walking or running process because of the leg, each and every step involved in the middle of the sand, and it is very highly friction process. That's why if we use the shoes made with the plasticized PVC, our the process nothing but either walking or running is very flexible when compared to the without that making shoes. So next we see the physical properties of the PVC, that is nothing but a density and economics, hardness and strength of the material. So first of all we see density. So density nothing but PVC is very dense compared to the most plastics. So PVC is the most very high density by preferring the most type of the plastics. And economics, PVC is readily available and cheap in cost. And hardness, so rigid PVC is very hard. And strength, rigid PVC has extremely good tensile strength, Okay, so after that we see economical versatile polyvinyl chloride is used a variety of the applications in the various of the building and construction. So this type of the PVC is called as a unplasticized PVC. And healthcare, electronics, automobile and other sectors in the products ranging from piping and sliding, blood bags and tubing to wire and cable installation. So this type of the PVC is nothing but a plasticized PVC. That means windshield system components and more amounts of the applications coming out from this polyvinyl chloride PVC polymer. So, and finally you see there are many uses of PVC as a rigid plastic. So it is used as a vinyl siding, magnetic stripe cards, window profile, pipe plumbing and contained fixtures. PVC is commonly used as the insulation on electrical wires. That means because of the property of the plasticity, they are bad conductors for electricity. So after that we see another polymer nothing but Teflon. So Teflon is nothing but a tetrafluoroethylene or fluorine. So this Teflon is nothing but a tetrafluoroethylene. So generally we know the formula of the ethylene. So what is the formula of the ethylene? Ethylene means, what is the general formula? CnH2n. So ethylene means if N is equal to 2, C2H4. So this is the formula for ethylene, and it is the structure like this is the structure for ethylene. So if you can replace the surrounding if you replace the surrounding 4 hydrogen atoms of the carbon atom by the most highly electronegative element of the entire periodic table, so that is nothing but fluorine. Then it is called as a tetrafluoroethylene, tetrafluoroethylene. So that means this Teflon is obtained by the polymerization of water emulsion tetrafluoroethylene under the pressure in the presence of benzyl peroxide as a catalyst. That means already we discussed about the catalyst in the previous PPTs and at the present PPT. Nothing but catalyst is a substance in order to improve the rate of the reaction without involvement of the product formation. So that is nothing but a Teflon. So in this case we observe the tetrafluoroethylene. Generally the 4 fluorine atoms present as a hydrogen, that is nothing but ethylene. We see the structure, and that 4 hydrogen atoms are replaced by the 4 fluorines, that is nothing but a tetrafluoroethylene. So, and it is undergoes a water emulsion polymerization. Which polymerization? Water emulsion polymerization in the presence of a peroxide catalyst. And it give a polytetrafluoroethylene. Polytetrafluoroethylene. So that is nothing but a Teflon. Okay, so Teflon is also called as fluon. What is the alternative name of the Teflon? Is nothing but a fluon. That means due to the presence of highly electronegative fluorine atoms. Why you called it fluon? Because of the four hydrogen atoms of the ethylene are replaced by the more electronegative atom of the entire periodic table. So that is nothing but fluorine. So that's why this is called as a fluon. So what are the elements present in fluorine group? Nothing but chlorine, bromine, iodine, and astatine. So this is highly active elements present in the seventh group of the periodic table. Okay, so out of all these elements in this group, the fluorine is most electronegative element. So not only in this group of the entire periodic table, fluorine is acts as a more electronegative element. So that's why this is called as a fluon. Okay, so presence of highly electronegative fluorine atoms, and these are strong attractive forces is responsible for the high toughness and high chemical resistance towards all the chemicals except hot alkali metal and hot fluorine. Hot alkali metal and hot fluorine. That means alkali metal. Alkali metals means they are present in the first group and the second group of the periodic table. For example, if we can say taken as a first group, that is nothing but hydrogen, lithium, sodium, potassium, rubidium, and cesium and francium. So totally 7 elements of the alkali. And we go to next group, second group. That means only 6 elements. That means beryllium, magnesium, calcium, barium, strontium, and radium. So that is nothing but here. The 6 elements of the second group of the periodic table. So that means due to presence of highly electronegative fluorine atoms, these are strong attractive forces is responsible for the high stiffness and high chemical resistance to the almost all the chemicals. That means either in the presence of acid or alkali, and except hot alkali metal and hot fluorine atoms. That means it is very highly stable in the presence of acid or alkali, but only that condition is not applicable in the case of the hot alkali metal and hot fluorine. Okay, so that is the exception property of the Teflon. And what are the uses of the Teflon? So it is mainly used for the making seals and gaskets, which have what are the uses of the Teflon? It is mainly used for the making seals and gaskets, which have to withstand very high temperature. That means it is also used for the insulation of the electrical items and for making non-sticky surface coating, and particularly for the cooking utensils. That means Teflon is used as a insulating material for motors, transformers, cables, wires, fitting, etc. Okay, so most probably these are applicable for the seals. So most probably it is commercially called as M seal. So, for example, in order to prevent the leakage of the water pipes, especially we use the M seal item. So, it is the commercial name of the Teflon. And gaskets. So, gaskets means especially we observe in the fitness of the cooker door. Cooker cap. So that is nothing but a gaskets with only they can avoid the leakage of the vapor, and which have the withstand very high temperatures. For example, if cooker is heating on the gasware and it will be goes to very high temperature, even that very high temperature, the material should be standby and exhibits the highly stable material. So because of the fluorine atoms involved in the preparation of the fluorine, so that is nothing but a Teflon or a fluon. So it is also used for the insulation of the electrical items, and for making non-sticky surface coating, particularly used for the coating utensils. That means Teflon is used as a insulating material for motors, transformers, cables, wires, and fitting, etc. Okay, thank you.
Like, share, and subscribe. Hit the bell icon for more updates.